this is Dr. Mears, and I am doing properties of a normal distribution today for my IB Math Studies 2 students. The example that we're doing, I didn't use, this isn't true real data, so hopefully the manufacturers of coconut milk won't mind me using this data. It's just an example. I did get it out of one of our textbooks, so hopefully that'll be okay. All right, so let's read our example. I'm just going to zoom back here so you can get the full picture. It says, coconut milk has become very popular at Starbucks. Packets of coconut milk are normally distributed with mean volume of 255 milliliters and a standard deviation of 8 milliliters. Sketch a normal distribution diagram to illustrate this information, indicating clearly the mean and the volumes within 1, 2, and 3 standard deviations of the mean. So you get this question a lot. This is just sketching our normal density curve. We have to understand a few things about the normal curve. So let's just kind of review back in history where our normal curve came from. So we will get to the answer to that question in 1 second. So here is a picture of a histogram, and let me try to center that for you. This histogram is a proportion of heads, and we've been working on histograms. I've had you do even group frequency histograms, and we have to remember that the bottom axis, or the x-axis, this is going to be our proportion of heads. So what we're doing here is we're flipping a coin. Here's our frequency, so this is how many times that we flip it, and the percentage of heads that come up, or the proportion of heads that come up every time. So we flip it 100, 200, 300, 400, 500 times. And so what's been happening with this distribution is that it's getting taller and taller. The frequency is getting more about the true mean, which is 0.5. Because we know when we flip a coin, we have a 50% chance that it's heads and a 50% chance that it's tails, which is the proportion of 0.50. Now, if we look at this histogram a little bit closer, and the next step that I usually had you do is to draw a nice curve that fits the graph. Actually, that's a little bit off, but you get the idea. I feel like I should try it one more time. I want to fit the data a little bit better than that. Okay, so bear with me. Here we go. One more time. Let's fit the data really closely. Here we go. And so I would probably ask you, which would be the next question of, what type of shape does this distribution look like? And hopefully you would say, well, it looks pretty symmetric, and you might even investigate what the mean and median are of this distribution, and that would be our next property that we would look at of this distribution. So we did a histogram, we drew in our density curve, we're predicting that it's going to be symmetric, and hopefully what we find is we find that the mean, median, and mode are the same number. And when that happens, we do have a nice symmetric curve. And it's symmetric about the mean. So this is our first property of a normal distribution. It forms a nice bell curve that is symmetric about the mean, which also represents mean, median, and mode being approximately the same number. Then, looking on, what we're going to investigate is our density curve, which is that nice smooth curve that we see. Also, we have -1 standard deviation, -2, and -3 standard deviations. +1 standard deviation, +2, and +3 standard deviations. So now we're actually also looking at spread. And this is going to bring us back to that first question that we have to answer, which is sketching a normal distribution diagram to illustrate the information. So here is our nice density curve of our normal distribution. And I even have for you where the mean goes, where -1, 2, and 3, +1, 2, and 3 standard deviations. We have to do some math before we can start, so I'm just going to go over here. First, let's write down what our mean is. Our mean is 255 milliliters, which they gave us in the problem. Our standard deviation is 8 milliliters, which also they gave us in the problem. They told us it was a normal distribution, so automatically you draw that nice curve. And we're going to put in 255 milliliters in the middle, because that's what we're going to be talking about the most, is that middle. So knowing what the mean and standard deviation are, let's find what 1, 2, and 3 standard deviations are. So 1 standard deviation is really 1 times 8, which is 8 milliliters. 2 standard deviations are 2 times 8, which is 16 milliliters. And 3 standard deviations is 3 times 8, which is 24 milliliters. Now that we know that from our mean of 255, adding 1 standard deviation means we're going to be adding 8 milliliters. This is your standardized measurement that represents how far an observation is from its mean using a standardized unit. So our standardized unit for this problem, calculated out, is 8 milliliters. 2 of those are 16 milliliters, and 3 are 24. We now need to find from our center, if we add one of those 8s, or one of those standard deviations, what we're going to get to. So let's do some work up here. So we have our mean, which is 255. We want to know if we add 1 standard deviation, or one of those 8 milliliters, what we're going to get, and we're going to come out with 263 milliliters. And so that's the number that you would write underneath your mu plus 1 standard deviation, 263 milliliters. Let's do minus 1 standard deviation. So we have mu minus 1 standard deviation. So we're going to take our 255 minus 8, and we're going to get 247 milliliters. And that's what we're going to write out in our diagram, 247 milliliters. We are now showing that from our center, increasing by 1 standard deviation gets us to 263 milliliters. Going back to our center, decreasing by 1 standard deviation gets us to 247 milliliters. Let's go a little bit further out. Let's look to see what our 2 standard deviations would look like. So going back to do the math, I might do 1 and 2 plus 1 plus 2. Right, sorry. So plus 2 standard deviations. So that's going to be 255 plus, and remember 2, I have it over here, is 16. And that's going to give us to 271 milliliters. And I'm going to do minus 2 as well. So 255 minus 16, and that's going to get us to 239 milliliters. Filling those numbers in down here, 271 milliliters was our plus, and 239 milliliters was our minus. Let's go out even further, which you can see is really way out there, and that's 3 standard deviations away from our mean of 255 milliliters. So let's calculate that over on the side. So mean plus 3 standard deviations is mean plus 24. Remember that was, our mean is 255. Plus 24, which gets us to 279. And our mean minus 3 standard deviations, which was 255 minus 24, and that gets us to 231. Let's put those numbers. 279 milliliters for plus 3, and 231 milliliters for minus. So now you can see from our mean, increasing by 1 standard deviation gets us between 247 and 263, increasing and decreasing. Increasing, decreasing by 2 standard deviations, 239 to 271. Increasing, decreasing 3, 231 to 279. There is a way to check, and it's by doing this. Let's start at our 231. If we add 8, we should get to that next number. So 231 plus 8, 239. Excellent. If we add 8 again, we should get to the next one, 247. Adding 8, 255. Adding 8, 263. Adding 8, 271. Adding 8, 279. So here we can see that we're increasing by increments of 8, which is what we did. However, I really wanted to hit home by saying, we really are increasing it from the mean. That's what we're really doing. We're adding and subtracting standard deviation from the mean. So you can definitely go through and check to make sure that you're increasing by your standard deviation increment, but just make sure you understand it is all about the mean. Okay, so that was our sketching a normal curve, inserting 1, 2, and 3 standard deviations. This is what it should look like. Notice I even have my milliliters labeled. And I'm going to zoom out a little bit to show you all of the work that I did. And if you need to pause and review, you can rewind that. I'm hitting 10 minutes and 39 seconds, so I'm going to be moving on to my next lesson in this segment. My next lesson in this segment is going to be looking at what the standard deviations tell us. And so we're going to look to see the standard deviations are down here. So this is -1 standard deviation, +1 standard deviation, and this is from our mean, and now our mean is 0 because our mean is at that center, so it's 0 standard deviations away from itself. So that's where our mean would be located. And we see that 68% of the data is located between 1 standard deviation. Between 2 standard deviations, we see that 95% of the data is located there. And within 3 standard deviations, way out there, we see that 99.7% of the data is located. Why is this important? And we are going to be coming back to this diagram. This is important because we're going to have to answer other questions. And the first other question that we're going to have to answer is finding a probability. And we're going to be finding the probability that a packet contains less than 239 milliliters. Now notice this is 68, 95, 99. I'm going to put in a little 0.7 here because that's what I do want you to use, is that 99.7. And this is what I explained with 1, 2, and 3 standard deviations. It would be nice to enter our numbers in there. So let's put our numbers that we had, that we just calculated, and this is why it's important to calculate your numbers out. Let's put in our standard deviations and our mean. So here was our mean, 255 milliliters. 1 standard deviation was 263, 2 was 271, and 3 was 279. -1 was 247 milliliters, -2 was 239 milliliters, and -3 is 231 milliliters. We're now looking at probability, so we have to look at the area underneath our curve. And when I talk about area underneath our curve, let's just veer over here. What I'm talking about is here's our axes and here's our curve. The area underneath of it is the area that I would color in here. This is the area, and I would color in, and I would not go out the lines, and I would keep coloring, coloring, coloring. My 4-year-old likes to color. We're practicing on staying in the lines. And so that whole area colored in, area under curve, is equal to 1 or 100%. So when you hear me talk about area under the curve, I'm talking as if I colored the area, the actual area in. So, back to our question. Find the probability that a packet contains less than 239 milliliters. So we know some of the breakdown of our normal distribution and what area underneath the curve represents by our percents here. The first way to do this is by looking at the 239 and locating it on the graph. So I'm going to look, 239, here we go, and put a little star there. Here's our 239, it's at 2 standard deviations. And I'm also going to circle the direction. This tells us what area to look at. This says less than. So here I am at my 239. Let's shade in less than. And so this gives us a nice visual of what area I'm talking about. So I'm talking about this area. Now notice, we have -2 standard deviations. 95% of our information is located between 2 standard deviations. However, there's some area outside that we did not calculate the percent for. because as I said before, the area under the curve is 100. We know that 95% is within 2 standard deviations. So let's go back to that first diagram that we looked at. It was this one. Try to center it for you so our 3 standard deviations are in there. Okay. This diagram, go up a little bit further. There we go. So here we have, and even looking at 95% is within 2 standard deviations, so we still have this area outside. This 2 standard deviations all the way through. 2 standard deviations all the way through. So 95%, if we have 100% under the curve, and we know 95 is in the middle, what does that leave us? That leaves us with 5%. However, we have 2 sides. Since we have 2 sides, we're going to have to take this 5 and divide it by those 2 sides. What does that leave us with? That leaves us with 2.5%. So 2.5% is above 2 standard deviations, and 2.5% is below 2 standard deviations. So 95 is in the middle, and 2.5% are on both sides. This can be broken down even more. We can even look to see 68%, which is in between 1 standard deviation. If we're looking at 68%, which is just this middle, we see that we have some left over on these sides. So what happens with less than 1 standard deviation, this big area here, and what happens with greater than 1, this big area here? Doing the same type of calculation is going to leave us with 16%. Now this is getting sort of messy, and we can break it down as far as you want. One picture that I did find online, and that was really nice, was this one. This one states 1 standard deviation, 2 standard deviations, and 3, and I would make this 99.7. You're going to see 99 a lot. However, 99.7 is what we do use in our statistics class. And you can see even they broke this down, 34 and 34. If we added 34 and 34, we get 68. If we added these 3 together, we're going to get 16. If we added these 2 together, we get 2.5. So this is a nice diagram that you can find online. If you just Google normal curves, you're going to be seeing different diagrams like this. So you can always pause this video and take a picture with your phone even. But trust me, this is a nice one to have. So knowing that, let's go back to the problem that we were looking at. And we're going to notice that we're at 2 standard deviations. That means that 95 was in the middle. We just determined that 2.5% is left above and 2.5% is left below. So since we're at 2 standard deviations, we're looking at below, we now know that our probability, we're going to have a 2.5% chance. However, when writing this in a complete sentence and they ask for probability, we're going to say that the probability is 0.025 that a packet contains less than 239 milliliters. Now that's one way to answer the question correctly because they asked for probability, and probability is a number from 0 to 1. There is another way to answer it that is correct, and that's by saying that we have a 2.5% chance that a packet will contain, not change, chance, contains less than 239 milliliters. Okay, on to the next question. I'm almost at 20 minutes here and I don't want to go too far, but this is the next one. Find the probability that a packet contains more than 239. So again, locating our numbers here, 239, let's remember, was at 2 standard deviations. Put a little star on it. We locate what direction? More than. And I circled that up here. We want more than. So we're at 239. There's our nice line from the curve all the way down. So let's shade in more than. Let's also put what we know. We know that this was already 2.5% here. And we know that the entire area underneath is 100. So all we need to do is subtract 100 minus 2.5. And we're going to get 98.5. So we have a 98.5% chance that, oh, no, mirrors. See what I did there? That was 1.597. Stop. 97.5. I'm sorry, that actually still looks like a 1. Okay, we have a 97.5% chance. I do know how to subtract. I was just going really fast. 97.5% chance that our packet contains more than 239. Let's go to the next question. Again, I'm going to put my numbers in, but let's do the question first. Find the probability that a packet contains less than 255. Oh, hey, 255 was here. 255, that was our mean. We know that because it's always about our mean. Let's look to see what direction they want. They want less than. Okay, well, here's my mean. Here's my line. Let's shade in less than all this. Hey, that looks like it's about, you guessed it, 50% of my curve, under the 50% of the area under my curve. And this other side would be 50% as well. So that means that less than my mean, we have a 50% chance of it happening. So the probability that a packet contains less than 50% is 0.50, or you can say we have a 50% chance that a packet contains less than 255 milliliters. So the proper way for writing the probability is in 0.50. You could, however, say it's a 50% chance. Okay, let's go our last one. Our last one. We randomly select 75 packets. Find the expected number of packets that contain more than 247 milliliters. Now, to find this, we need two things. We need the number of observations, which we have, 75. And we're going to need the probability. Sorry, I was shaking the table. I'm trying to write pretty quickly. So we would definitely put our numbers in again, 255, and I'm just going to put milliliters here so that we know that they're all milliliters. We have 263, 271, 279, 247. Oop, that's what we need. I'm going to mark that off already. 239 and 231. Sorry, excuse me. So we have find the expected number of packets that contain more than. Here's our direction, more than. So let's go down here. Let's shade in more than. We notice it is 1 standard deviation. So we know that here is 95. We know that this was 16%. And this side is going to also be 16%. So we have 95% here and 16 on our sides, because if we add those up, it's going to be 100, which is the area under the curve. We wanted more than, so to find our probability here, what we're going to do is we're going to take that 95, because that's in the shaded region, and add our 16, because that's also in the shaded region, and when we add that, it's going to be 111. So our number of observations are 75. Whoa, 111? How is that possible? 95. What mistake did I just make? Come on, this does not add to 100. 111? That's a percent. Can we go over 100? Heck no. Let's go back. Let's slow down a little bit and rethink about this, because this is not correct. First of all, this adds to over 100. So I use the incorrect percents. This is 95. So let's compute down here. 100, which is our area, minus 95 leaves us with only a little 5%. Okay, how many sides do we have? We have 2 sides, which leaves us with 2.5% for each side. That seems a little bit better. 2.5% here and 2.5% here. Now we're going to add 95 and not 16, but our 200 and actually, wow, I just did the whole thing wrong because we're not at 95. We're at 68. You know, now I'm thinking, should I post this whole entire thing? But it's okay. You need to see me make some mistakes too. 95, remember, is between 2 standard deviations. But we're only between 1 standard deviation, which means this is 68. Which does leave our 16 here and our 16 here. So we have 68 plus 16, which seems so much better. That gives us 84. So this is 84%. Yay! So our probability that contains more than 247 is 84. We're going to turn this into 0.84. The reason why we need that is we need the probability. The expected number comes from when you multiply the number of observations times our probability. So we're going to multiply 75 times 0.84. 75 packets times a probability of 0.84, and we're going to get 63. So our expected number of packets, expected number that contain less than 247 milliliters is 63 packets. Okay, there we go. Thank you very much for listening.